Hello! In this video we will talk about the basics of both LEDs and resistors. Let's start with LEDs. LED is an abbreviation for light emitting diode, which already explains a bit of the working principle. A diode only allows current to flow in one direction, which is why the orientation of the LED is important. Furthermore, the LED is designed so that when the current flows through the diode, energy is released in the form of light. The energy is released because the energy levels of the electrons decrease when they go through the diode. An LED has two terminals, the anode, which is the positive terminal, and the cathode, which is negative. They can be told apart by their lengths, as in most cases the cathode is the shorter one. When connecting an LED to a circuit, you have to make sure that the current is not too large. The current in a circuit can be limited by a suitable resistor. Let's discuss resistors next. Resistors are passive electrical components and create electrical resistance in a circuit. Resistors are used, for example, to reduce current flow, adjust signal levels, and divide voltages. The most important properties of a resistor are specified by the color-coded bands painted on the resistor. Watch our other video on how to understand them. The bands specify the resistor's resistance, tolerance, and in some cases, temperature coefficient. A resistor with higher resistance limits the current more than a low resistance one, as expressed by Ohm's law. For example, a LED can usually handle between 10 to 30 milliamperes. If we use a 5 voltage power supply, such as the Arduino, a commonly used transistor is the 220 ohm one. A 220 ohm resistor allows a current of around 23 milliamperes to flow in the circuit. Next, we will demonstrate how to control an LED with an Arduino and how to build the circuit. To follow along, you will need an Arduino, a breadboard, an LED, a 220 ohm resistor, and some hookup wires. First, connect the used digital pin to the resistor. Here we are using pin 13. Then connect the longer positive leg of the LED to the resistor and the shorter leg to ground. We are using one of the example codes, Blink. It can be found from the Arduino IDE under File, Examples, Basics, Blink. The program uses pin 13 to turn the LED on and off. The same pin is also connected to the built-in LED on the Arduino. Then let's take a look at the code. First, the mode of the pin is set as an output in the setup function. In the loop, we use the digital write function to turn the LED on and off. The 1000 millisecond delays specify how long the LED is turned on and off. That's everything for this video. Thank you for watching and see you in the next one.